The universe is a place of breathtaking beauty, but it is also a place of unimaginable danger. Every night, as we look up at the stars, we often think about wonder, exploration, and discovery. Yet hidden among the countless objects moving through space are potential threats, traveling at incredible speeds, some fast enough to change the course of human history in a single moment. Imagine an object hurtling through space at 64,000 kilometers per hour. At that speed, there is little room for error. There is little time to react. A single asteroid or space rock of sufficient size could carry more energy than the most powerful weapons ever created. It would not care about borders, politics, wealth, or technology. It would be a challenge faced by all humanity together. The question is not whether space contains dangerous objects. We know it does. Scientists discover new near-Earth objects every year. Most pose no threat, but history reminds us that impacts have shaped our planet before. Entire ecosystems have changed because of events that began millions of kilometers away. Today, humanity is more prepared than ever before. Powerful telescopes scan the skies. Advanced computer systems calculate trajectories. Space agencies and research organizations around the world work together to identify potential risks long before they become emergencies. For the first time in history, we are not simply waiting for fate. We are actively watching the heavens. But detection is only the first step. Finding a threat means little if we cannot respond to it. That is why planetary defense has become one of the most important scientific efforts of the modern age. Engineers are developing technologies designed to alter the path of dangerous objects. Missions have already demonstrated that humanity can slightly change an asteroid's orbit. A small change made years in advance could prevent a future catastrophe. Yet challenges remain. Not every object is discovered early. Some approach from difficult angles. Others are small enough to evade detection until they are much closer. Time is our greatest ally, but it can also become our greatest enemy if warning comes too late. This is why investment in science matters. This is why international cooperation matters. Planetary defense is not a problem one nation can solve alone. The sky belongs to everyone, and so does the responsibility of protecting our world. A high-speed cosmic threat exists. Asteroids and other space objects can travel at speeds of around 64,000 kilometers/h, carrying enough energy to cause devastating damage if they collide with Earth. When most people think about dangers facing our world, they imagine threats that originate on Earth, natural disasters, conflicts, or environmental challenges. Yet beyond our atmosphere exists another category of danger, one that travels silently through the darkness of space at astonishing speeds. Some asteroids and near-Earth objects move at velocities reaching 64,000 kilometers per hour or even more. At such speeds, even a relatively small object can release an enormous amount of energy upon impact. The faster an object moves, the greater the force it carries, turning what might seem like an ordinary rock into a potentially catastrophic threat. The vastness of space often creates the illusion that collisions are unlikely, but history and scientific observations tell a different story. Thousands of objects regularly cross Earth's orbital neighborhood, and while most pass safely by, the possibility of an impact can never be completely ignored. Unlike many threats that provide visible warning signs, an asteroid approaching from deep space could remain unnoticed until it is dangerously close if not carefully monitored. This reality makes continuous observation essential. What makes these high-speed objects particularly concerning is not only their velocity, but also the unpredictability of space itself. Tiny gravitational influences can alter trajectories over time. A harmless object today could become a future concern if its path changes. Understanding and tracking these fast-moving celestial bodies is therefore one of humanity's most important scientific responsibilities, helping ensure that we are prepared for challenges that may emerge from beyond our planet. Earth has faced similar threats before. Planetary impacts have influenced Earth's history, proving that cosmic collisions are real events that can dramatically change life on our planet. Earth's history is filled with evidence that powerful events from space have shaped the planet in dramatic ways. Long before modern civilization existed, massive asteroids and comets collided with Earth, leaving behind enormous craters and triggering environmental changes that affected life on a global scale. These impacts were not rare myths or scientific fantasies. They were real events that helped influence the course of evolution and the development of ecosystems over millions of years. Scientists have discovered impact sites across the world, providing clear proof that our planet has experienced cosmic collisions throughout its existence. One of the most significant lessons from these discoveries is that Earth is not isolated from the rest of the universe. Our planet travels through a dynamic solar system filled with countless rocks, debris, and celestial objects moving along complex paths. Most remain far away, but some occasionally cross Earth's orbit. The geological record serves as a reminder that even a single impact can have consequences, lasting for generations or longer. Studying past impacts helps scientists understand the risks we face today. By examining ancient craters, analyzing asteroid fragments, and using advanced computer models, researchers can estimate how future collisions might affect the environment and human society. The history of planetary impacts teaches a simple but important lesson. Space threats are real, and preparation is far wiser than assuming such events can never happen again. The past provides valuable knowledge that can help protect our future. Modern detection systems are improving. Advanced telescopes, satellites, and tracking technologies continuously monitor the sky to identify potentially dangerous objects before they become immediate threats. Humanity has entered an era in which the skies are being watched more carefully than ever before. Across the globe, powerful observatories, space-based instruments, and advanced tracking systems work continuously to detect and monitor objects moving through our cosmic neighborhood. Their mission is simple but critically important: identify potentially hazardous asteroids long before they have any chance of becoming a threat. Every day, scientists collect enormous amounts of data, analyzing the positions, speeds, and trajectories of countless celestial objects. This constant vigilance gives humanity valuable time to understand and respond to possible dangers. Modern technology has transformed what was once impossible into a routine scientific effort. Sophisticated telescopes can detect faint objects millions of kilometers away, while powerful computers calculate their future paths with remarkable precision. Artificial intelligence and automated systems help researchers process information faster than ever, allowing new discoveries to be confirmed and tracked efficiently. These tools enable scientists to predict close approaches, years or even decades in advance. Despite these advances, the work is never finished. Space is vast, and many objects remain undiscovered. Some asteroids are difficult to detect because of their size, composition, or approach angle relative to Earth and the Sun. This is why monitoring programs continue to expand and improve. The goal is not only to discover new objects, but also to build a complete picture of our surroundings in space. Every new detection strengthens humanity's ability to anticipate potential risks and make informed decisions, turning knowledge into one of our strongest forms of planetary protection. Planetary defense requires action, not just observation. Detecting an asteroid is only the first step. Scientists and engineers are developing methods to alter the paths of dangerous objects and prevent future impacts. Detecting a potentially dangerous asteroid is an important achievement, but detection alone does not guarantee safety. Knowing that a threat exists is only the beginning of the challenge. The real test comes when humanity must decide how to respond. If scientists discover an object that could collide with Earth in the future, the next step is finding a way to prevent that collision. This is where planetary defense moves beyond observation and enters the realm of action. Researchers and engineers around the world are exploring technologies designed not just to track asteroids, but to influence their paths before they become a danger. One promising approach involves changing an asteroid's trajectory by a very small amount. While the adjustment may seem insignificant, even a tiny change made years in advance can result in a completely different position by the time the object reaches Earth's orbit. Scientists have already demonstrated that it is possible to alter the movement of an asteroid through carefully planned space missions. These achievements mark an important milestone in humanity's ability to defend itself from natural cosmic threats. However, successful planetary defense depends heavily on timing. The earlier a threat is detected, the more options are available for preventing an impact. A late discovery could significantly limit possible responses. This reality highlights the importance of continued research, technological innovation, and international preparedness. By combining scientific knowledge with practical action, humanity increases its chances of protecting the planet from future dangers that may emerge from the depths of space. Global cooperation is essential. Protecting Earth from space threats is a challenge that affects all humanity, making international scientific collaboration and long-term investment in planetary defense crucial for our future. Threat from space does not recognize national borders, political systems, languages, or cultures. If a large asteroid were on a collision course with Earth, its consequences could affect multiple countries and potentially the entire planet. This is why planetary defense cannot be the responsibility of a single nation. It requires cooperation on a global scale. Scientists, engineers, governments, and research institutions must work together, sharing information and resources to ensure that potential threats are identified and addressed as effectively as possible. The challenge is too large and too important for any one country to face alone. International collaboration already plays a significant role in monitoring near-Earth objects. Observatories, located in different parts of the world, contribute valuable data, allowing scientists to track asteroids with greater accuracy. Space agencies and research organizations frequently exchange information, helping create a more complete picture of potential risks. This collective effort improves humanity's ability to detect and understand dangerous objects before they become emergencies. Global cooperation is also essential when it comes to developing defensive technologies and planning responses. Decisions about how to handle a potential impact could affect billions of people, making communication and coordination critical. By working together, nations can combine their expertise, technological capabilities, and scientific knowledge to create stronger planetary defense system. In many ways, protecting Earth from cosmic threats represents one of humanity's most powerful opportunities to unite around a common purpose. It is a reminder that some challenges are best met not as separate nations, but as one human civilization.